Good morning students. Let's go for the some problems based on the Henry's law. Okay. So, I will remind you once again, Henry's law is partial pressure of the gas in the vapor phase is directly proportional to mole fraction, which is converted in the form of P is equals to Kh into X, where Kh is the Henry's law constant. Okay. So, on the basis of this formula, we are going to solve the problems. Okay. Here, what is the problem? If N2 gas is bubbled through water at 293 Kelvin, there is a N2 gas which is bubbled in the water at around 293 Kelvin. Then what is the question? How many millimoles of N2 gas would dissolve in 1 liter of water? It means they have asked how many millimoles of N2 dissolved. It means number of moles of the N2 they have asked, and assume that the N2 exerts partial pressure of 0.987 bar, given that value of Kh is 76.48 kilobar. Okay. So, let us go for the problem. So, what they have given? Write the given quantity given. Assume that the partial pressure of N2 they have given. It means the partial pressure P N2 is equals to 0.987 bar. Okay. And another thing, what they have given? The value of Kh they have given. Kh is equals to 76.48 kilobar. Okay. So, we have to convert this kilobar in terms of bar, because both the units must be same. Either you can convert this into kilo, or you can make this kilobar into bar. So, I will make this only as in terms of bar. 76.78 into 10 to the power 3, this is 76,480 bar. Okay. So, this is the value which we can convert in terms of bar. Now, what is the question? How many millimoles of the N2 is dissolved in 1 liter of the water? So, let us go for the Henry's, according to Henry's law. According to Henry's law, P is equals to Kh into X, that is for the nitrogen gas. Okay. Then in this, what are the values we know? We know the value of P and 2, we know the value of Kh. Let us separate out the mole fraction of N2 is equals to what will be the term? P partial pressure of N2 divided by value of the Kh. Okay. So, the partial pressure of the N2 is already given 0.987 divided by, we are converting this in terms of bar, 76,480. So, when we calculate these two, that is 0.987 divided by 76,480, it will be approximately around 1.29 into 10 to the power minus 5. Okay. As it is mole fraction, there is no unit, the value will be 1.29 into 10 to the power minus 5. So, we come to know that the mole fraction Xn2 is equals to 1.29 into 10 to the power minus 5. But actually we do not want mole fraction. What we want? The number of nitrogen, the number of moles of the nitrogen dissolved in 1 liter. So, what is Xn2 is equals to? Mole fraction is equal to number of moles of that component divided by total number of moles of all the components. So as N2 is dissolving in water means there are only two compounds, one is N2, one more is H2O. So what we need to calculate? We need to calculate number of moles of N2, this term. So keep in mind that here the value of this number of moles of N2 is less as compared with the number of moles of water. That's why this number of moles of N2 in the denominator is neglected. Because the number of moles of nitrogen is less as compared to the number of moles of water. So see here, this xN2 value we know already. What is the value? 1.29 into 10 to the power minus 5. Okay, and then I need to know N2, that is number of moles of nitrogen, and this term is neglected means you have to leave that term. Okay, don't take this term as it is neglected. Now number of moles of water. What is the number of moles of water formula? Mass divided by molar mass. Okay, W by M. So now mass, we have to take the mass or weight of the water. How will you calculate? See here, there is a one clue, 1 liter. So 1 liter means 1000 gram. 1 liter means 1000 gram. So the number of the water molecules, that is weight, will be 1000 divided by molar mass. What is the value of molar mass of water? That is 18. So when we calculate this, it is approximately N2 divided by 55.55. If you calculate 1000 divided by 18, it's around this much. Therefore 1.29 into 10 to the power minus 5 is equals to N2, that is number of moles of nitrogen divided by 55.55. Okay. Now what I need to calculate? I need to calculate the number of moles of the N2. So the number of moles of N2, N2 is equals to 1.29 into 10 to the power minus 5. Okay, this term, that is 55.55, is divided here, that it will be multiplication. So what is the value? Into 55.55. So when I multiply all this, you are going to get 7.16 into 10 to the power minus 4 will be the answer. Okay, so here it is in the denominator, it gets multiplication for this value. So the value of this, when you calculate, it will be in terms of 10 to the power minus 4. Okay, so this is mole, number of moles of the nitrogen. But what is the question? How many millimoles? They have asked this answer in terms of millimoles. So milli means 10 to the power minus 3. Milli means 10 to the power minus 3. So if I convert this into in terms of millimole, it will be at around 0.716 millimole. Okay, so this is the required answer. So why it is so? It is in terms of mole. So separate this 10 to the power 4 as 10 to the power minus 3 into 10 to the power minus 1. 10 to the power minus 3 means millimole term came. Only what left? 10 to the power minus 1. 7.16 into 10 to the power minus 1 means it will be 0.716 millimole. So this is how we can explain the problem. So what they have asked, how many millimoles? So that only we have calculated. First make use of the Henry's law, find out the value of mole fraction of the N2, and so that you will going to get the value of xN2, and by using this we can able to calculate the number of moles of N2. See here, number of moles of N2 is 0.716, it is very less as compared with the number of moles of water, which is 55.55. that is why this term is neglected in the denominator. This term is neglected in the denominator. So, you are going to get 1.29 into 10 to the power minus 5 is equals to NN2 divided by 1000 divided by 18. It will be around 55.55. If I calculate NN2, it will be 7.16 into 10 to the power minus 4. So, I convert that into millimoles, that is converted in terms of millimoles. Finally, you are going to get 0.716 millimole. So, this is the first problem. Okay. Next, we will go for the second problem. So, in case of second problem, what is the question and what they have asked, we will see. I hope so all of you got the first one. Let us go for the second one. So, here H2S is a toxic gas with rotten egg like smell, is used for the qualitative analysis. H2S is a hydrogen disulfide, is a toxic gas which is having the rotten egg like smell, and that is used for the qualitative analysis. That is used for the qualitative analysis. If the solubility of H2S in the water at STP is 0.195 molal, M term indicates molal. So, here M will be molal. Keep in mind, because that will be very useful for our calculation, which is given as a hint itself. Okay. So, calculate the Henry's constant. They have asked the Henry's constant. So, let us go for the solution. So, what they have given? 0.195 molal solution means .19 moles is dissolved in 1 kg or 1000. Why kg? Because it is molality. If it is molarity, you are not going to take in terms of kg. Okay. So, as it is a molal solution, we are going to take that in terms of the kg. So, 1 kg is nothing but 1000 gram. 0.195 solution means 0.195 moles is dissolved in 1 kg of the water. Okay. So, now according to Henry's law, P is equals to KH into X. What is the question? We need to find out KH. We need to find KH, and here it is of H2S gas they have given. You can mention this term. Okay. Now, KH is equals to, what is the value of KH? KH is equals to PH2S divided by XH2S. Now, PH2S, for this there is a one clue in the question that it is taken in terms of STP, standard temperature and pressure. So, at around standard pressure and temperature, you have to take the pressure as 0.987 bar. Okay. Whenever the pressure, whenever they have mentioned STP as a clue, you have to take the pressure, that is the partial pressure in the vapor phase of the gas is 0.987 bar. And then now 0.987 divided by, this one I need to calculate. this one I need to calculate. As you know, X H2S, this I will separately calculate here, or else you will might be some confusion. X H2S is equals to N H2S divided by N H2S plus N H2O, that is the number of moles of the hydrogen sulfide divided dihydrogen sulfide and then water. So, here number of moles of H2S, how to find out? See here, there is no need to calculate a number of moles of the H2S, because they have already given that this molar solution. So, directly we can say that 0.195 molar solution means 0.195 moles. This is the number of moles of H2S which is dissolved in 1000 gram of the water. So, directly I am going to take NH2S as 0.195, no need of any calculation. Why there is no need of any calculation? Because they have mentioned 0.19 molar solution. So, it means that 0.195 moles itself. Okay. So, now as I said you that in the denominator this must be neglected, because 0.195, that is the number of moles of H2S is negligible as compared with the number of moles of the water. Then how to find out the number of moles of water? So, here they have mentioned mass divided by molar mass, again it is 1000. So, I will take here 1000 divided by 18. 1000 divided by 18. So, 1000 divided by 18, it will be 55.55. Okay. Then if I go on calculating this one, you are going to get 0.0035. 0.0035. So, this is the mole fraction of the H2S. So, this term I need to calculate, which I have calculated in this way. Here this term is neglected because the number of moles of H2S, that is 0.95. This 0.195 is less as compared with 55.55. So, it is this term is left out. So, come to this point, that is mole fraction of H2S is 0.0035. Okay. If I calculate this one, you are going to get the value of KH as 282 bar. 282 bar. So, this is how we can able to find out the value of the Henry's constant. Since in this question they have given the two hints, one is a molar solution, it means this number of moles are dissolved in 1000 gram of water, and then STP means you have to take the value of P as 0.987, and according to this only, this molar solution we have find out the number of moles of water. So, by substituting this all term, you are going to get the Henry's law constant as 282 bar. Okay. So, in next video we will go for the further examples.